Good morning, students. My name is Nandini, lecturer in mechanical engineering. So I am dealing the subject of a basic thermodynamics. In that, the first chapter is the fundamentals of thermodynamics and perfect gas laws. For the main objective of today's class is the definition of thermodynamics, thermodynamic system, thermodynamic properties, state, path and process, quasi-static process, reversible process and thermodynamic cycle. So first coming to the what is thermodynamics. So the name itself indicates thermo means heat, dynamics means, so all of you know that the dynamics means motion. So heat plus motion is nothing but the thermodynamics. So coming to again, once again I will repeat what is thermodynamics. So thermodynamics means the science deals with the conversion of heat energy into mechanical energy, and the properties of the system is called thermodynamics. The term thermo means heat, dynamics means motion. This conversion is based on a certain laws generally known as law of thermodynamics. So example, I taking that metallic rod and heating on one side. After some time, the other end will also heat. Why? Because this, so heat is transferring from one place to another place in a span of a short time. Another example is, so when you touch the stove, boy touched the hot stove by mistake and feels the stove very hot. Why this? Because so thermal energy is transferring from the stove to the hand. In coming to the second case, here when the boy feeling cold on handling the ice in his hand, big here is the reason happening. The piece of ice in a case is reversed because your hand is warmer than ice, so thermal energy is passed out of your hand. From these two examples, what you can say, heat always flow from a higher temperature to lower temperature, and heat flows due to temperature difference between two objects. So the first, heat always flows from higher temperature to lower temperature. In the first case, at the stove is a higher temperature and the boy hand is a lower temperature. So heat is flowing from the stove to the boy's hand. And coming to the second case, the boy and in his hand he is holding some ice, but here the heat is transferring from the hand to the ice. Hand to the ice means our body having the our body is warmer than the ice, so heat is flowing from the higher temperature to the lower temperature. Nothing but the heat flows due to temperature difference between objects. And in general, in engineering applications, we use this a thermal power plant. Thermal power plant will produce the electrical energy by converting the coal or oil into the electrical energy. And in automobiles also we can use it as the heat energy is converted into work energy which drives the vehicles. So in general applications and in the engineering applications also we can use the thermodynamics only. General applications: rise the temperature of water in kettle, cool our room on a hot humid day, heat up our room on a cold winter night. And coming to the thermodynamic system. Thermodynamic system. Previously we learned what is thermodynamics. Now it is a thermodynamic system. So what is thermodynamic system? In this thermodynamic system, it mainly consists of a system, boundary and surrounding and universe. The region in the space that contained matter whose behavior is to be investigated is called thermodynamic system. So the behavior of the whatever the matter contained in the space, that behavior we can investigate it is called the thermodynamic system. So now is a blank, is a white screen, you are seeing it as a universe. In this universe I am drawing one circle. I am separating that the I'm separating the universe. I'm with a so drawing a circle. So means system, that the circle part, whatever the circle inside the called system, outside is called the surrounding, and we, is there a line between the system and surrounding is called a system boundary. So whatever the matter inside the body is called system, outside the system is called surrounding, and which separates the system and surrounding is called the system boundary. What is the surrounding means? The region in the space that contain matter whose behavior is to be investigated is called thermodynamic system, and referred to as a simply as a system, and the system enclosed by a boundary. Outside the boundary is called the surroundings. Outside the boundary is called the surroundings. These so this system classified is into three types. One is a closed system, second one is open system, and third one is isolated system. So the name itself indicates a closed means the same example we take one beaker inside the liquid and close it with a cap. It is a closed system. Open system means the flask without beaker is called open system. Isolated system means to the flask I am insulated with a one material is called an isolated system. So first coming to the closed system. Closed system. In this closed system, so only energy transactions will involve. No mass transactions are not possible in the closed system because we closed the flask. We closed the flask. So observe that the flask, we are only heat energy transactions only going on with the heat in and heat out. Heat is into the system, heat out to the surroundings. So this a closed system contains a fixed quantity of a matter and has no mass transfer across the boundary. Only energy transfer may take place across a system boundary. So there's a two parameters are there here. One is heat and mass. So for the closed system, only heat in into the system, heat into the surroundings, heat in and heat out, and there is no mass transfers across the boundary. You can clearly understand. So what is the closed system is only energy transactions or the heat energy transactions only in the surroundings, no mass transfer takes place in the closed system. Next one, second one, what is the second one? Is an open system. Open system means both the open system. So in the open system, for the same flask, I removing the cap. I am removing the cap and I am giving the heat, and some vapors are coming out. Here both the heat and the mass transfers are the takes place. Open system is a one that permits the transfer of matter and energy across the boundary. Energy across the boundary. Here one point we also to note that, so whatever the matter enters and whatever the matter enters or leaves may be equal, may not be equal, may be equal or may not be equal. The mass confined within the boundary may change or it may be a constant. Here both the mass and the heat are both are changing. Here heat in, heat out, mass in and mass out. Whereas in an open system, only heat and heat transfer is only taking place and mass is a constant. So this is the difference between the open system and in the closed. Next, coming to the isolated system. Isolated, the name itself indicates is an isolated, means is the no interactions between the system and the surrounding. So it has a fixed mass and energy, and here there is no mass and energy transfers across the system. This one is the no heat transfer and no mass transfer we are insulating with a one thermoflask, like a thermoflask. So thermoflask is not a completely isolated system. For the particular time, only particular time, if you pour the hot water or hot water, it will stay like that only. So there is no heat transfer, there is no mass. Coming with for the three: open system, closed system, isolated system. So the two parameters, mass and the heat. In the open system, there is only mass and heat transfer. In the closed system, heat only heat transfer is there, no mass transfer. In isolated system, no heat transfer, no mass transfer. So thermodynamic system is mainly divided into three types: open system, closed system, and an isolated system. So closed system is nothing but the uh, is a one involves only the energy transactions with surroundings. Thus, a closed system contains only a fixed quantity of a matter and has no mass transfer across its boundary. Means only energy may flow across the system boundary. So, for example, we consider the gas contained in a cylinder is a good example of the closed system. In this case, the boundary itself, the boundary means piston itself change the position as when the gas expands or contracts. When the gas expands or the contracts, this is the best example for the closed system. So once again I am telling about the closed system. So closed system is a one that involves only energy transactions with surroundings. Thus, a closed system contains a fixed quantity of a matter and has no mass transfer across its boundary. On only energy may flow across the system boundary. Only energy means only heat transfer takes place. No mass transfer takes place in the closed system. Only heat transfer takes place, no mass transfer is there. Best example is the gas contained in the cylinder. Best example is the gas contained in the cylinder. In that cylinder we have a piston. The piston is moving up and down from TDC to BDC, BDC to TDC itself. As the gas expands, when the piston moves from one position to other position, and contracts when piston moves from one position to another position. This and the mass is a constant in that only, and mass is a constant in the cylinder. This is the example for the closed system. And coming to the open system. So in the open system, it permits only if that permits both mass and the heat means nothing but the energy across the boundary. The rate at which the matter means whatever the mass enters and leaves may not be equal or may be equal. The mass will be confined with a boundary, may change or it may be constant. In engineering applications, the examples of the open system is a flow of a steam through the nozzle and flow of air through the compressor are the examples of a open system. What are the examples in the open system means flow of a steam through the nozzle and the flow of air in the compressor are the examples of a open system. And coming to the isolated system, isolated system is a one that involves no transactions with the surroundings. Thus, it will not permit the transfer of both the matter and energy across the boundary. So, here there is a no mass transfer and there is no heat transfer across the boundary, and it is totally unaffected by the changes in the surroundings. So, if you take a pan containing a hot water kept in an isolated box, and a thermoflask containing a fluid are the examples of a isolated system. The universe can be considered as an isolated system. The universe can be considered as an isolated system. So here are the three are the thermodynamic system. First one is a closed system, second one is open system, third one is a isolated system. So the two parameters, mass and the heat. In the open system there is a mass and heat are there. In the closed system no mass transfer, only heat transfer is there. In isolated system no mass and no heat. So I hope that all the students will understand what is an open system, closed system and an isolated system. So first one is the intensive properties or intrinsic properties. These are independent of the mass of the substances. These are the independent of the mass of the system. So intensive properties is a clear concept. To understand the intensive properties means if you consider an amount of a matter, if you consider an amount of a matter which has a uniform temperature and we divided into different parts or examples, so two parts. So say take a uh, one amount of a matter and divided into the two parts. The mass of the whole is the sum of the masses of the parts. Means for the first one it is a m1 and second one it is a m2. Their sum means m1 plus m2 is equal to m, means overall mass is equal to the sum of the two parts. M1 plus M2 is equal to M, and like that is a volume, overall volume also. So overall volume is V and the sum of the volumes are V1 and V2. So volume V is equal to V1 plus V2. Volume V is equal to V1 plus V2. And like this the temperature, but the temperature is not same in the intensive properties. The temperature of the whole is not the sum of the temperature of the parts, and it is the same for the each part. It is the same for the each part. So mass and the volume are the extensive, but the temperature is an intensive property, but the temperature is an intensive property, whereas as a mass and the volume depends upon the depends upon, as a mass is depends upon volume is depend upon the mass. So is that the dependent of the mass of the substance is called the intensive properties and independent of the mass of the substance is called an extensive properties. So examples for the extensive properties are the pressure, density, specific volume, thermal conductivity, temperature, specific gravity and surface tension. uh, and next coming to the extensive properties. The extensive intensive property, so they are dependent on the mass of the substance. Example, mass, enthalpy, internal energy, weight, entropy, etc. are the examples of the extensive property. So mathematically also we can write like this: intensive property is equal to extensive property divided by mass, because intensive properties are independent on the mass. So the property which is divided by the mass means there is a no mass and mass are the cancel. So that is independent on the mass is nothing but the intensive property. That is nothing but the intensive property. So for the is the density, you can consider as a density. Density is equal to, what is the density? Density is equal to mass by volume. Density is equal to mass by volume. So what is an intensive property? Intensive property is equal to extensive property divided by mass. So here we are taking this is a intensive property as a density, we are taking as a intensive property. So mass by volume. Extensive property is by mass. Here mass and mass cancel. So density is a independent on a mass, independent on the mass here. So it is called as an intensive property. Intensive property like that. And specific volume is also an intensive property. Specific volume is nothing but the 1 by V. It is also independent on the mass. So it is called as an intensive property. Intensive. Some examples of the intensive properties: boiling point, color, temperature, luster, hardness are the examples of intensive properties. Volume, mass, size, weight and length are the extensive properties. So here is, so next is the state, path and the process. So state is nothing but uh, the condition, the state means refers the condition of the system at which it exit. So the state of the system is described with the properties such as temperature, pressure, volume, density, etc. Is called the state of the system. State of the system. Two independent properties are sufficient to represent the state of the system. Means if you consider the pressure and the volume, and we draw the PV diagram, means pressure and volume diagram. So pressure P1 to V1, pressure P1, volume V1 changes its states to P2 to V2. So changing the points from P1 to P2 is called the one state to another state. PT to another V1 to V2 is another state. This is called the state. Next, path. So the series of a states through which the system passes during the change of the state is called the path. So uh, initial state is P1, final state is the P2. So P1 we will draw P1 to P2. Here is the diagram. So initial state to diagram represents from initial state to final state. This the line represents the path, means arrow represents, so going from initial stage to final state, the arrow represents the path. So the path describes the infinite number of states that occur when a system undergoes a particular process of from a one state to another state. So the line joining the series of states through which the system passes in going to the initial state to final state is called the path. The next coming to the process. Process is used to denote the change in the system, in the state of the system. In the a system undergoes a process where it changes from a one state to the another. So thermodynamic processes are usually investigated by a PV diagram or the PV or TS diagrams. Next coming to the quadratic process. This is nothing but quadratic process means static means equilibrium, quasic means slowly. So the process involved in a involved in such a manner that the system is in equilibrium or nearly to the equilibrium from initial stage to final state. So the process is called quasi-static process. So the process during which the state remains almost in equilibrium or in equilibrium from one state to the another state is called a quasi-static process. So here I'm considering one cylinder. In that cylinder is a piston, and in the inside the piston some gas is there. So outside here the diagram represents is the system initial state, and the inside the gas is called the system boundary and the final state. So consider a system initially is in a equilibrium. As it weighs on the piston, just balances the upward force by balance upward force exiting by the gas. If all the weights are removed suddenly, the piston will move rapidly up to it stops. Means the system changes from initial state to final state, but the intermediate states are not in equilibrium, and hence the process is not quasi-static. So once again I will repeat. So first the system is initially in equilibrium as the weights are on the piston, just balance the upward force. Just balance the upward force. If all the weights are removed suddenly, the piston will move up rapidly. The piston move up rapidly up to the final state. The system changes. Here the system changes from initial state to final state, but the intermediate states are not in equilibrium, and this process is not quasi-static. If consider the second case, the process in quasi-static process. When it becomes a quasi-static process means the same weights remove in a small magnitude one by one. Then the piston moves slowly upwards up to its final state. At final states means intermediate points. See the PV diagram in the intermediate points. This is double line indicates that slowly we are removing the weights. So first point, second point, third point, 4, 5, 6, 7, 8. Like this, here we are removing the weights equally, and that it's not moving the from suddenly from initial state to final state. Instantly means equilibrium states. If you are removing the load in equilibrium states means double lines indicates that the equilibrium states. At any instant, the upward position of the piston, the system is nearly to the thermodynamic equilibrium. So thus the intermediate states between the initial and final states are in will be in equilibrium. And observe that the double lines of the each 2 points are in the same distance. Such a process is called a quasi-static process. Quasi is nothing but the meaning slow. Static means equilibrium. So if you take the cylinder inside the piston and where they put the weight on the set from initial stage to final state, if you remove the weights, all the weight suddenly, the piston goes from initial to final state in single state in single time. So there is no removes rapidly it go and it stop. Means the intermediate states are not in equilibrium. The intermediate states are not in equilibrium. Whereas coming to the quasi-static process means if you remove the weight slowly, if you remove the slowly one by one, the piston moves slowly up to its stop at to its state. So it reaches the initial stage to final state, and that intermediate points are all are in a equilibrium states. So how will you define the quasi-static process means? It is a process involved that the system is in equilibrium or nearly to the equilibrium from initial state to the final state. Then the process is called a quasi-static process. Reversible process. A process that can be reversed so that the system restored to its initial state is called a reversible process. So the word itself telling that the reversible process. The process can be reversed so that the system can restore its to its initial state is called the reversible process. Thus the reversible process follows the same path. So the system should be a reversible means it must be a quasi-static process, and then what is the thermodynamic cycle. So thermodynamic cycle is a sequence of a thermodynamic process that begins and ends at the same state, and that the system is returned to its initial state. If you start the process at 1 and it again will return uh, final state, and again after completing the cycle also both the initial and the final states are the. So here I am considering the PV diagram. State point 1 and 2 are the states, and arrow represents the path, and A is the process. So 1 to 2 is one process. Again 2 to 1 is again another process. B represents a path. Here we observe that the system changes from state 1 to state 2 by process A. So system changes from state 1 to state 2 by process A, and system changes from and return to initial state from 2 to 1 by the process B. So the sequence of the process A and B constitute a thermodynamic cycle. So the whole cycle means 1 A, B and 1. This represents the thermodynamic process. So in this class totally we learn about the what is thermodynamics, thermodynamic system and thermodynamic properties, state, path, process, quasi-static process and reversible process, thermodynamic cycle. So these are the topics we learned today. So in the next class we discuss about the pressure, temperature, volume and standard conditions. Standard conditions means STP and the NTP. STP conditions and the NTP conditions because of a temperature, pressure And energy forms means heat and work, how heat conversion and work symbols in next class we will discuss about. So thank you so much.